This is part 5 of the first lecture of week 9. Here we will look at the important property of the Laplace transform, which is called translation in S. Let me formulate the theorem. If the Laplace transform of some function f, let's denote it for capital F of S, exists, let's say for some s larger than, let's say, some alpha, then the Laplace transform of the function EAT times f of t, this is equal to capital F, and here we got a translation by A, and this exists for all s larger than alpha plus A. Let's prove this result. The proof is very simple. So we calculate the Laplace transform of e to the at f of t at a point s. By definition, this is integral from 0 to infinity e to the minus st times the function, which is e to the at f of t dt, or this is integral from 0 to infinity. We can combine the powers of the exponent. We obtain s minus a here, t f of t dt, and this is exactly the Laplace transform of the function f at this point s minus a. And the Laplace transform of the function f exists for s larger than alpha, so now it exists for s minus a larger than alpha or s larger than alpha plus a. So the proof is finished. Let's consider an example. Assume that we want to find Laplace transform of EAT, let's say, times sine BT. And we found that the Laplace transform of the function sine BT at a point s, this is b over s squared plus b squared. So using this fact, we just translate. So this is our f of s, right? And this Laplace transform by theorem, which will be f s minus a. So we just substitute instead of s here the difference s minus a. So the answer is b over s minus a squared plus b squared. So this is Laplace transform of e to the at times sine bt.